Welcome back, and in the end of the last segment we asked you to evaluate a pull rod subjected to an external load of 2000 newtons. Calculate the stress for the cases where it is manufactured from a rod of diameter of 10 millimeters and a 10 millimeter tube of 1.5 millimeter thickness. And to help you out, we actually gave you the answers of 25.5 megapascals and 49.9 megapascals, and I'm just going to run through the solution quickly for you to give you the confidence that you've got those answers in the correct manner. So we utilise the fact that stress is equal to force divided by the area, and then we use our little trick that we've been learning, that if this is the force on the top, then the area is inverted on the bottom. So we say it's pi d squared divided by 4, but it occurs on the bottom. And working the numbers out there, we get 4 times 2000 over 100 pi, which will come to 25.5, our first answer. The only thing to remember with the diameter of for the tube is the fact that this time we have 1.5 thickness either side, which means we've got to take away 3 from the original 10 millimeters, and it's just the difference in the outside and inside diameters. So there we have a modified formula, if you wish, common sense formula. We've got our 2000 as normal, and then the 4 over 10 squared minus 7 squared, an effective diameter if you wish, multiplied by pi. If you do the numbers, we have 4 times 2000 over 51 pi, which is equal to 49.9, almost double the stress. Okay, now time to move on for a final exercise, which will come back, and my colleague Dr. Namani will take you through the solution for this, and then you can, once you've completed this solution and the homework, it's probably time to have a look at what you could be doing in our workshop. So this is an exercise that pulls all our everything we've done within this lecture together, hopefully. This time we have a square bar, so nice and easily, a 20 by 20 square bar and a length of 400 millimeters. If the bar is subjected to 1000 newtons, we need to use some definitions of stress and strain to show that the displacement can be expressed as this. We evaluate the stress and strain in the bar, hence or otherwise, that means use what you've developed before in the question, or by your own methods, extension under the load, and describe what you'd expect when the bar exceeds its elastic limit. So a little bit of explanation. These are the type of examination type questions you could expect in our full module. So not just a taster module, but you're getting the first part ideas of how you can become stress analysts with questions of this type. So if you'd like to have a go at that and then come back to us, then we'll go through the solution in the final segment.